Hello again, Chiming here in South Australia, riverine floodplain. Today's project is to establish this monitoring system with telemetry capacity to measure a few things. So the first thing we measure is the moisture below the ground. So you can see in the front we've got the flag, and underneath the flag we used a driller to drill to a depth of 4 meters, and then we put moisture sensors underneath and then backfill with the floodplain muds. So this is the floodplain muds, so you can see it's cracking everywhere. And this place used to be flooded back in 2023 floods. You could also see some footprints from, this is likely emus going there, some lignums and red gum. And so these sensors were in, so the drill is 150 millimeters. And then the sensor was pushed on the wall to sense the moisture, salinity and temperature. So 1 meter each interval, 4 meter, 3 meter, 1 meter near the surface. And then every sensor comes with a cable. And then we basically bury the cable all the way towards the station, which is 25 meters. This is actually a very heavy task. Because we have another one also 25 meters, and then digging a hole and then backfill with dirt takes almost 1 day of my effort. So it goes like that way and then towards the station. Now what the station measure, it's basically a full weather station. So it measures temperature, humidity, wind speed, wind direction, solar intensity. The top vertical post is the antenna, so that is able to transmit the data online. And here we've got a solar panel, so that powers up the lead acid battery installed inside. We might just have it open up and see what is inside here. So if we open it up, so you can see we've got power, solar regulator, dart logger, and modem. So all the sensor comes from the bottom and connected to the system, and it's basically service free. So we ensure that there's no leaking. There are spikes, bird spike we haven't installed, which prevents birds sitting here and then poo here as well. And also prevents insects like ants is one of the issue. We once had a case where it's full of ants. Ants really like this kind of hot enclosure inside. And so I'll close it. Right. Now, what else we measure here? This is another borehole. So it also goes the other way towards another borehole, again 4 meters below ground, measuring the moisture profile. And if we go further up, there is a borehole. So it's a monitoring borehole, which drill down to groundwater table and then measure the piezometric pressure of the groundwater. So that's the overall situation. Now, why are we doing this? So this floodplain is full of clay, which is quite impermeable. But it's getting dry. We were getting dry over time. So in the last 10 years, the last flooding was back in 2011, and we come here in 2021. The clay was completely dried. And now the current situation after the floods, the mud was fully water saturated. So even though the surface looks like very, very dry, but if you dig, say, 1 meter then it's getting completely wet because the water table is just about 1 meter below the ground. So now imagine within 10 years, this cycle will happen again where the clay becomes completely changed from the completely wet condition to completely dry condition. So there are two possible processes that is taking place. One is evapotranspiration. So that takes water away from the top. The other thing is the groundwater drainage. So currently the water level is just 1 meter below. But as we know, river Murray water level is going down because the drying years start to come. So the groundwater table will reduce to from 1 meter to roughly 6 meters below ground. And then there will be drainage as well. And the drainage process is a bit funny. So once it's drained down, water table drops. And then the drainage will allow the reduction of the moisture within the clay. But in the meantime, it reduces the hydraulic conductivity. So once the clay hydraulic conductivity is reduced to a certain level, the groundwater table will be changed from an unconfined condition, as we see here, is a confined, so we can drill and then find the water table, to completely confined condition. And if it's confined condition, we can even see that underneath the clay, the groundwater head is actually within the sandy aquifer below, so it doesn't come to the clay at all because the reduced hydraulic conductivity of the clay. So this is a clear process that a aquifer that is able to convert from a confined condition in the dry season to an unconfined condition, as we see right now. So that just gives an overall indication of what the project is about. Hope you enjoy it. If you have any question, just give a comment. Thank you.